Okay, we're going to work on linear, quadratic, exponential, and inverse variation. The word model here just means that which one does it look like, okay? So let's get started on this first one. Write this down on your marker board. I don't want that one. And now, if you like this written down across, then write it across. Do you prefer making it into a table? That's your choice how you write it down. So now what you have to do is you have to take these points and decide if it is linear. If it's, I spelled that wrong. If it's linear, then what will be the same? Common differences. Your first differences will be the same. It's up to you. For quadratic, what will happen? Second differences, quadratic. Second differences are the same. Okay? The third thing is exponential. And what will happen to the y values for exponential? Yes, they are multiplied by something. Okay, if it's a number greater than 1, then it is growth. If it's a number between 0 and 1, then it's called decay. And the last one is inverse variation. And with inverse variation, you have to multiply the x times the y, and it gives you the same number. All right, is this linear? No. Is it quadratic? Yes. If you look at it, it's actually really easy because you see 0, -3, -4, -3, 0. Check this out. X-intercept, x-intercept. What's this guy right here called? The y-intercept and the vertex. It's obviously quadratic. If you do your common differences, you're going down 3, down 1, up 1, up 3. It's not linear. Now let's do the second difference. This is going up 2, from -1 to 1, up 2, and 1 to 3 is up 2. So it is quadratic. You're exactly right. So that's the first thing you're going to have to be able to do is find out what it is. All right, then I have to write an equation. For quadratics, you don't know enough in your math life to know the exact equation. So we're just going to kind of give an approximate equation, okay? If it's a quadratic, what do you know about the x? It's squared. So it's going to be x squared. What is the y-intercept? -4. So all you're going to write down right now is x squared minus 4. Now, no, that's not exactly right, okay? It is not all the way right. But I'm just showing you, you just have to get a general idea of this. Okay, so write the second one down. If you would like to do it as a table, do it as a table. You have to decide, go through all 4 different ones and decide which one it is. Okay, so first of all, we said it's not linear because it doesn't have common differences. It's not quadratic because the second differences are not the same. Inverse variation means that all of these multiplied would equal the same number. 4 times 1, 2 times 6, it's not that, so it's got to be exponential. This one's kind of hard. Okay, I taught you yesterday something about dividing. 4 times what gives me 6? Okay, do you remember what we said? We said take the 6, divide by 4. I might want to use a little blue calculator. Take the 9, divide by 6, take the 13.5 and divide by 9. So you're taking the y value and dividing it by the one before it. Check to see all 3 of them. You should get the same number each time. And that is going to be blank times something to the x. And what did you get? 1.5. So that means that it's multiplying by 1.5. Is that growth or decay? That is exponential growth. Growth has a number. The b value is greater than 1. Okay, now what's this right here? The y-intercept. But is that 1, 4? Is that the y-intercept? No. I've got to work backwards to the 0. Right. So I'm going to take my 4, divide it by 1.5, and that's going to tell me where it started. 2.6666, thank you, 2.7. So my y-intercept is 2.7. I got 2.7 by taking the 4 and dividing by 1.5. So when I go forward, I'm multiplying by 1.5. But when I work backwards, I have to divide by 1.5. And that gave me 2.66666, which is 2.7. And that's my y-intercept. When I'm moving forward in my table, what am I always doing? Multiplying by 1.5. But when I go backwards in my table, I'm dividing by 1.5. Why do I want to go backwards anyway? Find the y-intercept. Okay, so this is my final answer. Okay, we are moving down to the next one. This is our third problem. Write it down as a table or ordered pairs. Let's check the linearness. 9 to 0 is going down 9. 0 to -7 is down 7. -7 to -12 is down 5. Is it linear? No. Let's try it again. -9 to 7 is 2, and -7 to 5 is 2. What is it? It's quadratic. Now, since it's quadratic, this 2 right here has nothing to do with the equation except for to tell you it's quadratic. Okay? That's all we know in your life right now. In Algebra 2, you'll catch and get more in pre-cal. All right, so what do I know about quadratic? Y equals x squared. Oh my gosh, we got to find the y-intercept. I have to find my y-intercept. Well, the y-intercept is going this way, right? Keep listening. So I have -212. I have to get -1, and then I'll get the 0. Please watch. Don't be in la-la land right now. So -2, what am I going to do from the -12 to the next one? -3. And then what am I going to do for the last one? -1. So I have this -12 right here. I need to go 3 more down. So what does that give me? That gives me -1, -12 minus 3 is -15. See how it went 9, 7, 5, 3. What's next? 1. Okay, then I have to go 1 more down for that one. -16. So it's x squared minus 16. Okay, this is our fourth problem. First thing I want you to do is figure out if it's linear, quadratic, exponential, inverse variation. Let's work backwards. Is it inverse variation? If it was inverse variation, I could not have a 0 right here, because you can't have any zeros because you don't have any intercepts. Also, these would have to multiply to always give you the same number, and that's not true. Okay, so I think we're going to say this is linear because it's going up by 750 each time. Now, once I know that, does that have anything to do with my equation? Yes. What is it? That's the slope. This is the slope. So y equals 750x plus 15,000. That's it. Okay, I'm going to look at this. This goes down by 8, 2, 4, and then 3. So that is not linear. If I go out again, will these be the same? This would be up 6, down 2, and up 7. It's not quadratic. For exponential, I could do like this. 20 divided by 12. 10 divided by 12. 6 divided by 10. Those are all different numbers. Inverse variation is when you multiply them. $1.50 times 20 gives me what? 30. $2.50 times 12. 30. 3 times 10. 30. 6 times 5. 30. 10 times 3. 30. Okay, it's definitely inverse variation. Write your equation two different ways. X times y equals 30. Ooh, that's difficult. The other way you can write it is y equals 30 over x. Now, just for fun, and to remind you, what is the domain? We learned this yesterday for inverse. All reals, x cannot equal 0. Range, all reals, y cannot equal 0. Now, what if I had a 0 in my table right here? What would it say down here? It can't have anything. It would probably say error or undefined. If you see that, you know it's inverse variation. All right, so this is the last one. Go through each thing in your mind. Pause this. Try to do it without talking to me. So, y'all told me this is not linear. Because look, this is 1,000, and what is this? 950. So it's not linear. And if I go down here, I'm pretty sure that's going to be a number. It's not linear. And is it going to be quadratic? Not quadratic. What about exponential? Yes. Exponential, let's try it. I see that it's starting at 20,000. So that is called my y-intercept. Now, do you understand that if you don't know how to set up an equation for exponential, you're going to get these 3 wrong on the test. You have to know the formulas for the exponential and all that. Okay, now, if I take 1900 and divide by 19,000 and divide by 20,000, what do you get? 0.95. 0.95. If I take 18,050 and divide by 19,000, do you get 0.95? Yes. Maybe you want to check the third one, but yes, it is 0.95 to the x. The end.